In the last lesson, we looked at solving linear equations, pretty basic ones. Now we're going to look at how to solve equations that have fractions in them. Let's take a look at an example. X over 2 minus 5 over 6 equals 2x over 3. Now, equations that have fractions in them are inherently more complicated than equations that don't have fractions in them. So we really want to find a way to get rid of the fractions. That would be lovely. We would be so much happier if we could get rid of the fractions. Now, a fraction represents a division. This fraction bar represents division. This is x divided by 2. Here, this represents division, 5 divided by 6. So to get rid of fractions, we need to undo division, which we can do by multiplying. So what we want to do is use the rule that tells us we can multiply both sides of an equation by the same number. The thing is, we want to pick a number that when we multiply is going to get rid of all of the denominators, and the number that we want is going to be the LCD. So the rule says to remove fractions in an equation, multiply both sides by the LCD. I want you to write this down in your notes, maybe underline it, maybe circle it, maybe draw a cloud around it. If you've got stickers decorated up, this is a hugely important rule. We will be using this when we're solving equations with fractions now, and we're going to use it later when we're solving rational equations, which is much more complicated. And there are always students who don't follow this rule, and it leads to mistakes and frustration and heartbreak. And you don't want any of that. So please do yourself a favor. Anytime you're solving an equation with fractions, the first thing you want to do is get rid of them, and you do that by multiplying both sides by the LCD. Let's do that in this problem. The denominators are 2, 6, and 3. We need to find the least common denominator for those numbers, so the smallest number that's a multiple of all of them. And in this case, that's going to be 6. 6 is a multiple of 2, it's a multiple of 6, and it's a multiple of 3. So we are going to multiply both sides by 6. And you've probably noticed I put parentheses around both sides, and I put 6 on the outside of each of them. That's because that 6 is going to need to get distributed into each term. If you don't write it like this, you're more likely to make a mistake. So please do everything just as I'm doing it with these problems to avoid making mistakes. All right, now we're going to need to distribute that 6 on the left. When we multiply a whole number into a fraction, we multiply it into the numerator and then divide by the denominator. So to do this, we're going to take 6 times x and then divide that by 2. 6 times x is 6x, and if we take 6x and divide it by 2, that gives us 3x. Now we've got a subtraction here, and we're going to do the same thing here. We're going to multiply this 6 into the numerator. 6 times 5 gives us 30, and then when we take 30 and divide it by 6, we end up with 5. That's the rule. That's how we do it. The reason that 6 gets multiplied into the numerator is because if we wrote it as a fraction, that would be 6 over 1, and we know that when we're multiplying fractions, we multiply the numerators. So the 6 gets multiplied in with the x, and 1 times anything is itself. So we keep the denominator, and then we divide. Some of you may have noticed that the 6's here canceled effectively because we're taking 6, multiplying 5 by 6, and then dividing it by 6. You can do that, but you want to be careful that you don't actually cross them out, because then you might forget that this 6 needs to be multiplied into the first fraction as well. So I recommend doing things this way, but if you have a better way that you can use and still get the right answer over and over again, then that's fine. Let's look on the right-hand side. We need to multiply 6 times 2x. That gives us 12x. And when we divide 12x by 3, that gives us 4x. Perfect. Now that we've done this, we have an equation that no longer has fractions, and so it's much easier to solve. We have variables on both sides, so we need to get rid of one of those variable terms. I'm going to subtract 3x on both sides of the equation. When I do that, I'm just left with negative 5 on the left, and then on the right, 4x minus 3x is 1x, which is just x, and so our solution is negative 5 equals x, or you could write it x equals negative 5. All right, let's do a couple more examples. And then if you feel like you need more help, you can look at the linked examples below. Let's take a look at, let's see, z over 5 minus 1/2 equals z over 6. Okay, so here we need again to multiply both sides by the LCD. We need the LCD of 5, 2, and 6. And the smallest number that is a multiple of all of those is 30. So we're going to multiply both sides by 30. On the left, we'll have to distribute. 30 times z is 30z. When you divide 30z by 5, that gives you 6z. Then minus 30 times 1 is 30. Divide that by 2, we get 15. On the right, 30 times z is 30z, and if we divide that by 6, we get 5z. So we've got 6z minus 15 equals 5z. Again, we have variables on both sides. We need to get rid of one of these variable terms. I'm going to subtract 5z from both sides. And the reason I'm going to do that is because I like to end up with positive coefficients. 6z minus 5z is 1z, or just z. We also have the minus 15 on the left. On the right, they cancel, giving us 0. Now, we need to get z alone. We can add 15 to both sides. That gets z alone on the left. On the right, 0 plus 15 is 15. And we have our answer, z equals 15. We're going to do one more example now. Let's take a look at 7a minus 1 all over 5 equals a over 2 plus 7. Now this one's more complicated because we have a fraction on the left that has multiple terms in the numerator. And what we're going to do here is we're going to split it up into two fractions. We're going to write 7a over 5 minus 1 over 5. We're allowed to split it up when the multiple terms are in the numerator. It's effectively a version of the distributive property because here we're dividing both of these by 5, so we're really multiplying them both by 1/5, and so we can multiply them both by 1/5 separately. On the right, that gives us a over 2 plus 7, and then it's just like any other problem. We need to multiply by the LCD. In this case, the LCD is 10. Let's distribute on the left. 10 times 7a is 70a. If we divide that by 5, we get 14a. Then minus 10 times 1 is 10, divided by 5 is 2. On the right, when we distribute, 10 times a is 10a. Divide that by 2, we get 5a. Plus 10 times 7 is 70. Good. We've got variables on both sides. We can get rid of one of those variable terms by subtracting 5a on both sides. That gives us 9a minus 2 equals 70. Then to get the a term alone, we add 2 to both sides. 9a equals 72. And to get a alone, we divide by 9. 72 divided by 9 is 8. And so we've got our final answer, a equals 8. And again, there's plenty more videos if you click on the link below to look at more worked out examples.